Jimmy has an IQ measured at 143 if the average is 100, which is pretty normal, and the standard deviation is 15. Okay, what percentage of the population does Jimmy have an IQ higher than? So let's figure out Jimmy's z-score. So he's at 143, and the average is 100. So clearly he's above. And standard deviation of 15, which is actually true for the IQ test. They're designed to do that. So 143 minus 100 is that, divided by 15 is 2. Whoa, he did very well. That's a 2.87. We're going to go 2 decimal places because our z-tables allow that. And now remember that if we go, what percentage of the population does Jimmy have an IQ higher than? So this means that we are interested in everything to the left. He is almost 3 standard deviations. So he is higher than this percentage. He is way up there. So this is exactly what our tables do. So we want to look for the 2.87. 2.8 is right here. And we're going to go all the way to 2.7, which is right here. So that is 0.9978. So 99.78%, okay, he scores better than. That is very high. Samuel buys gas at a local gas station, McQuickie Mart. He pays $3.84 for a gallon. The average price is 2. Okay, so let's get that z-score. 3.84 minus $2.90 divided by 0.56. So 3.84 minus 2.9 equals divided by 0.56. So he is, he's got 1.68. A z-score of 1.68. So he paid for that. That's the average. That's the standard deviation. So is he overpaying? What percentage of gas stations charge more than this? Okay, so let's see. 1.68. Because we want to know the percentage that charges more than this, we want actually the right tail, which means we're going to have to subtract the z-score, okay, of this guy being less than 1.68 from 1. Okay. So 1.68 is all the way over here, right there. So 1 minus 0.9535. Okay, that'll give me the percentage. So less than 5%, so 4.65% are going to charge more. So he's paying a lot more gas there. Lindsay has an IQ of 125. And George has 109. What percentage of people have an IQ between these two? Okay, well, we already know the IQ is 100. We need 2 z-scores here. So let's do Lindsay. 125 minus 100 over 15. Let's get her z-score. Okay, 1.67. Okay, now let's get George's. And George's 109. Okay, so that's going to be 9 divided by 15. 0.60. Okay, now we want to know in between. So she's higher. So what we're going to do is we're going to find the z-table for L. Okay, and in the z-table, that is 1.67. That is 0.925 minus George's score. What is his? 0.60. 0.60 is 0.7257. So George did pretty good in 0.7257. Okay, so this will give me what what percentage scored in between. 0.925 minus 0.7257. So looks like we got about 22.7% scored in between them. So about a little over a fifth of population. Tim weighs 215. Tim weighs 215. The average weight of U.S. male is 181, so he's over. With a standard deviation of 26 pounds, he is buying a bike but wonders if it is strong enough. The bike company states that the bike is designed to accommodate 95% of the male population in weight. will Tim break the bike? So if it's going to be 95%, we need, well, let's just calculate his z-score right there. His z-score is 215. If you can't buy this bike, I'm going to feel sorry for him. There was actually my brother who has been overweight most of his life, like very much so. We were in line for the Raptor in Cedar Point, and he that's a Z-score. We waited 3 hours for this line because of, like, the Raptor had just like opened. You know, I was like late 80s, early 90s, and 3 hours, and they could not fit the chest piece over his shoulders. So after 3 hours, he had to like walk away from the coaster and not go on it. It was heartbreaking. But that's what they're doing. They're accommodating for a certain proportion of the population. And if they can't do it, then yeah, they got to turn you away. All right, so let's see. He is 0.131. 0.131 is right here. 0.9049. All right. Is he going to be able to buy the bike? He can because he is not. He's basically scoring right there, and they said they'll account for 95. So he just made it. So 95 would have taken us over here. 95 would have taken us to about right there. So 1.65. So he could have got up to 1.65, and then it would have been no good. He would not have been able to do it. Sally weighs 100 pounds. Average weight is 140 with a standard deviation of 18. Her doctor wants to put her on weight loss pills or weight loss medication. Explain why he would be concerned. Okay. Oh, well, not weight loss. He wants her to put on weight. Okay. Let's see here. She's 100. Let's figure out her Z. I totally read that wrong. 100 minus 140, 18. Let's get her Z-score. Negative 2.22. So that is she is way underweight. Let's see what percentage. She's in like the bottom. Let's see. Negative 2.22. Negative 2.22 is right here. She's in the bottom second. She's in the second percentile. Okay. Which means like 1.32% is like she weighs more than 1.32%. So she's way down there in the low percentiles. She is grossly underweight. So yeah, she's got to put on weight. All right. Where are we at? 8 minutes. Alexis runs a mile in gym class in 5 minutes and 15 seconds. The gym class averages 7 minutes with a standard deviation of 45. What percentage of the class is Alex faster than? Okay, I like that question because it means that Alexis, this is a left-hand tail, right? She's faster than this amount. But do not put 5.15 seconds or 5.15 as her variable, as her score. It's 5.25 because 15 seconds is a quarter of a minute. So this is how fast she is. But the average is 7 with a 45 seconds. So can't be 45. That is actually 0.75 minutes, right? So 45 seconds is 0.75 minutes. So we got to put this all in minutes or put it all in seconds, okay? It's up to you. It doesn't actually matter as long as you are consistent. So 5.25 minus 7 equals this. Divide by 0.75, and we get negative 2.33. Okay, so what I don't like, though, is the idea that, well, here, let's look at that because this has got an interesting twist to it. Negative Negative 2.33 is actually 0.0099. 0.0099. Okay. Now, what does this mean? It means that if we were to round this up, we've got 1% of people that will actually score lower than her. Now, lower in this case is faster. Okay, lower is faster. My mic was super far away. Lower is faster. So this means then that she is actually, we want the other direction, right? So you gotta kind of exercise your common sense here. Okay, so or is that how it goes? Yeah, I think that's it. So, or is that, I don't know. No, I'm actually going to calculate that. Okay, 0.9901. Okay, so she is faster than 99% of everybody there. Okay, and it is because this means that their scores would be lower than hers. That means that they would be faster. So we've got to invert this to think about who would be slower than her. Okay, so watch out for that. Okay, I think I'm going to stop it here and then finish out the last video with the last problems.